Okay, we're on page 170. Translate verbal descriptions into algebraic expressions with one variable using diagrams, or a lot of big words. Basically, what that means is you use the pictures and the words that are there to make an algebraic expression out of it. So, example 17, John's farm has a rectangular shape. So if they show that, that means you draw a rectangle, because you want a visual description to actually be able to help you with this. There's a rectangular shape. Its width is x yards. So it says x yards. Make that smaller. Width is x yards, and the length is 6 yards more than 1/3 of the width. So 6 yards more than 1/3 of means
multiplying
1/3 of the width. The width is that, so it means 1/3 of x. So 6 more than 1/3 of the width. You have to interpret every part of that. I don't want this. 6 more than 1/3 of multiplying the width. The width is x that they already told us. So 6 plus 1/3 x. Does it matter if it's 6 plus 1/3 x or 1/3 x plus 6?
it does.
Off.
Oh.
Does it matter with addition? Does the order matter?
No.
No. If this was subtraction, would it matter? Yeah. If this said 6 less than 1/3, then it would have to be minus 6. You can't just say, or you could say technically minus 6 plus 1/3 x, but that's a little bit more confusing. So 1/3 x plus 6, and then you have to actually do the multiplication to find the area. Is that what it asked for? Yeah. Write an algebraic expression for the perimeter of John's farm. So what do we know? How do you find perimeter of a rectangle? Yeah?
Side times 2 times side times 2.
Yeah. This times 2 and this times 2, right?
Yeah.
So I get, this is 2x plus 2 times 1/3 plus 6. Good? Wah, wah, wah. What's wrong? Yeah.
Simplify.
Nope. You do have to simplify, you're right about that, but there's something else that is wrong. If you get this answer and simplify it, you will have the wrong answer.
You wanna multiply 2 times 1/3?
Yeah, you all will multiply. That's part of the simplifying that he talked about. What's wrong with this? This is not going to give you the answer. Sure, you need to put yards.
There's
Sure.
another side.
No, because 1/3 x plus 6, 1/3 x plus 6, we did 2 times it. X, so we did 2 times it, including both. That will give you the full perimeter. So what's wrong? How long is this side? How long is this side? What?
1/3 x plus 6.
1/3 x plus 6. What do we multiply 2 times?
Oh, the 1/3 and the 6
Yeah, the 1/3 and the 6, which means we need to add what?
times 2.
Yeah, parentheses here, because you have to multiply the whole side by 2. You can't just say, I'm going to do 2 times this. This is a very common mistake. So make a note of it. Whenever it is, you have to make sure you put that in there. So now, sure, you'll distribute 2 over 3, because this is 2 over 1 times 1 over 3, plus 2 times 6 is 12, plus 2x. What am I missing? I dropped something. I didn't write it up there. What? What did I forget? I forget to write something from up here for down there. Nope. This is 1/3 x plus 6, and this is something dropped right out of the expression. What was it? 1/3 plus 6, 1/3 x plus 6. What drops?
Oh,
The X.
Yeah, the x. You might forget that sometimes too, so you gotta double check your work. So this becomes 2/3 x plus 12. The reason it occurred to me is because I was like, 2x plus 2/3 plus 12. Wait, why are these both addable? 2/3 and 12 I could have added together. Nope, can't add 2/3 and 12 because there's an actual x there. 2x plus 2/3 x makes
8. No.
no. 2x plus 2/3 x.
Wait, you wanna put on 1?
8x.
No. If you have 2 of something
No,
and you get 2/3
8/3
more of it, so you could say 8/3. Yeah, you could say 8/3 x if you want it in improper, or if you want it in regular proper, you could put it in. That's for you.
So you can put it 2.2.
Not 2.2, 2 and 2/3 x plus 12, or
8.
as he said, yes, you could put 8/3 x plus 12. Either way, you're gonna have to put parentheses around it and label it,
Yours.
yep, yards, because it's distance. It is one-dimensional. You weren't finding the area, you weren't finding the volume, you're finding the distance around the whole thing. So it's 2 and 2/3 x plus 12, or 8/3 plus 12 yards. The book does use 8/3 x plus 12, but either one is fine. Guided practice 2, why don't you guys start on that one?
There's no clue.
A clue for you, it says that Anne's garden is an isosceles triangle. What is true about an isosceles triangle?
There's no 2.
Bottom of page 170, number 5.
Yeah, fine.
Did I say 2?
Yeah, you said
Oh,
2.
sorry. That looks like a 2 if you put it backwards. Anne's garden is the shape of an isosceles triangle with a base of 2 y feet, and the sides is 2/5 y plus 3.
I can't remember.
If this is 2/5 y plus 3, what's this one?
The same.
Why?
They're literally the same.
Why? What kind of triangle is it?
Isosceles.
An isosceles triangle has what?
2 equal sides.
2 equal sides.
Oh, she just
That means that mark means it's the same thing. All right, I'll give you guys 2 minutes. If you get done with it faster, let me know. Label. Yep, add a label.
I was gonna say.
So it's 2 and 4 plus 1 plus 6 feet. So it's just 6 feet, 6 feet, what's the 2 and 4 plus? Yeah, that's right. You got it. If you want to go on and do
Mr.
this
Burnham,
kind of practice, if you get both of those, you can check the book and start this thing. So,
what do the lines mean?
lines mean that these are equivalent. So it tells you all you this in the assignment. It says each of the sides is 2/5 y plus 3. But even if they had only told you one, isosceles triangles always have opposite angles, and then opposite sides and opposite angles have the same. So the angle across from the side is going to be the same as the angle across from the other side. Anyways, so here, first thing we have to add is all the what? What do I have to add? Finding the perimeter.
2 plus y plus 3 plus 2 plus y plus 3.
Yeah, so we have to add all of them together. So let's just add all the y's together. 2y. 2/5 plus 2/5 is what? 4/5, but it's y, plus another 2y. 2 and 4/5 y, plus what? How many of actual numbers do we have?
2,
Yeah, and we add them up, we get
6.
6. If we wanted to put this in actual terms of improper fractions, 5 times 2 is 10, plus 4 is 14 over 5 y plus 6. And what's the label on these?
14.
2 times 5 is 10, plus 14. Plus 4 is 14 over 5.
Oh, I thought, okay.
Think about it. If you did it the other way around, 14 divided by 5,
Yes.
you would have 2, 4 left over. Denominator is 5. What's the label for these, though? What's the book say? Well, it's not square because it's distance around. But yeah, it's just feet, not feet squared. Not feet squared because you are not finding area. Alright, next one. Translate verbal descriptions into algebraic expressions with more than one variable. So that just means we're going to have, the only difference is before we had one variable, now we're going to have 2, maybe 3, but 2 for right now. So Andrew has M coins, Catherine has 1/2 R coins. So Andrew, Catherine, he's got M, she's got 1/2 R coins. That just tells you how many they each have. How many more coins does Andrew have than Catherine? So if you want to know how much more, like let's say this person's got 6, this person's got 2, what would you do to figure out how much more 6 is than 2?
2 minus 6.
Subtract? What? Subtract what from what?
2 minus 6.
Nope. 2 minus 6 is negative 4.
6 minus 2 is 2.
Yeah, 6 minus 2. So if we want to know how many more coins that Andrew has than Catherine, we have to do what?
Subtract
What?
6.
Well, we don't, these are the imaginary numbers.
Oh.
I was using those as an example so that anytime you're like not sure what to do, adding, subtracting, multiplying, dividing, just replace them with actual numbers you do know, and it usually makes a lot more sense. It's just that our brains have a harder time wrapping themselves around imaginary numbers, kind of. I mean, these aren't actually imaginary numbers. They're just variables because we don't know what the actual numbers are. So if you replace them with numbers you do know, your brain can make more sense of it, and then you can go back and do the actual thing you need to. So what do I have to do with these? Yep.
So M minus 1/2 or is that all?
Yep. And then label. It said how many more coins does he have? So I can put. Good? Nope. You're gonna wanna pay attention to this. What's wrong with the answer? Oh, I'm not gonna get the answer from you. I'm gonna get the answer from someone else. Yep. Yep. Otherwise, you're saying M, and you don't know what it is, minus 1/2 R coins. So, like, that's like saying, hey, I've got like, whatever M is, 265. Got 265 water bottles. I don't know what it is. We didn't put a label on it. Minus 1/2 R coins. Next. All right. Papayas, grapes, strawberries. So we're gonna say that has anyone here seen Seinfeld? No? You guys know what Seinfeld is? It's a TV show from the late 80s, early 90s. So it's really old. It's older than Friends even, so I only really recently got into it. But the one other guy is Kramer. He loves papayas. He always says papayas. He always calls them like that. So we've got grapes, papayas, and strawberries sold in the supermarket. The following prices. What?
Tagano? That
No,
sounded like
papayas. That's what-
Papayas. You sound like Tagano.
Well,
Papayas.
Tagano got that from your boy Kramer then.
Tigano is he's infinite.
All right, so we got grapes, papayas, and strawberries. And it's got a little picture there. Grapes are X dollars per pound. Papayas are Y dollars per pound. And strawberries are 3/5 X dollars per pound. So the only thing we really know, we know one is more expensive than what other one? Yeah?
Grapes and papayas are more than strawberries.
Well, we know grapes are more than strawberries because strawberries is 3/5 of it. But do we know how big Y is? No. Y could actually be smaller than 3/5 of X. Let's say Y is 1/2 X. We don't know what Y is right now, so we can't assume that strawberries are going to be more or less than papayas. But we know for sure strawberries cost less than grapes. Danielle bought 4.5 pounds of grapes, 2.65 pounds of papayas, 6 pounds of strawberries. What's the total cost of the fruit? So 4.5 pounds of grapes. What is it, 2.65 papayas? That's very specific, by the way, at the grocery store. Actually, when you measure them, I guess it does measure down to the actual tenth probably. And 6 pounds of strawberries. What do we have to do with all these? Not take an answer from you. If you bought 4.5 pounds of grapes, 2.65 pounds of papayas, 6 pounds of strawberries. When you see the word of, you think
English class.
multiplying, yes. Did you just say you think English class?
Yep.
Prepositional phrases, I hear what you're saying. That being said, of is more fun in math than it is in English class. I'm sorry.
Colin, you started a rant.
I didn't really get into the details. Page 115 in your book, Prepositional Phrases.
No.
4.5 times X plus 2.65 times Y plus 6 times 3/5 X. Oops, that's supposed to be X. And then we can just do this. Stick a label on it, we're good, right? What's up?
No, you're
You
not
have to
good.
add them.
I have to add them?
Yeah, the
Oh, this one's X and that one's Y, I can't add.
the other one, the last one
You
is
did
supposed to be, instead of, you put a fax and then you put 0.3.
6 and put what? 6 times 3 is
6 and 3,
18.
18 over 5x. So I've got 4.5x. And I'm just gonna, remember, these are all addition. So for right now, we can just move the 2.65y over here and just realize, hey, we're not gonna touch that. Can we add 4.5 plus 18 over 5?
no.
Yeah, that looks like not much fun actually. What do we have to do to add them? We have to get them both one way. Either they both have to be what or what?
Decimals or.
Decimals or which ones do you want?
Decimals.
You both want decimals? Okay. 18.5. Okay, look, 18 over 5. You can actually turn this into a decimal pretty easily. How? Yeah?
Multiply by 2.
That's. Oh, actually, you not multiplying by 2, multiplying by 2,
X
by 2,
over 2.
over 2, because that gets you the same thing. And that gets you 36 over 10, which is what is a decimal?
0.36.
That would be 36 over 100.
3.6.
3.6. And then you gotta put the X on it. That's actually, as creative. The way I was thinking actually was, look where this came from, 18 over 5. It was 6, oh no, it was 6 times 3 over 5. Yep, your way works better than mine. I was thinking this was 6 plus 3 over 5, in which case it would have been 6.6, but that was not the answer. So yeah, 3.6x plus 4.5x then we know we're gonna tag on 2.65y at the end. 4.5 plus 3.6 is,
A lot
Five,
of numbers.
5.1.
I think 4 plus 3 is,
8.1
yeah, 8.1.
X.
Plus 2.65y. Good? Yep. Alright, and then it shows you stuff in terms of like the graph and everything on the bottom, back to page 172. If you want to look on that, great, go for it. It doesn't really matter to me which one. And guide of practice. Number 7. 6 is pretty similar to what we did. Number 7, you're gonna have to put your thinking cap on a little bit more. Give me a second. Alright, you guys got 2 minutes. Okay, well you have to, so actually, you can get either one on this one. So, if you're saying quarters, dimes, nickels, so you said 0.250, this is 0.25 what, dollars or 0.25
Quarters.
cents?
But I put the parentheses at the beginning. And of half.
You don't have labels, you don't have your variables on here, because it said M quarters, 0.25 M,
Yeah.
0.5 N, and then 1/10 right there. So you need to put variables on these, and think this is this $0.25 or is that 0.25 cents?
Hmm.
This isn't a quarter of a penny, that's a quarter of a,
Dollar.
if it's a quarter of a dollar, then you can't, how can you put cents on there?
So I corrected, I didn't understand except for number 3, I didn't do B, so should I just do number 7?
Yeah, that's fine. Why don't you just do it on the same piece of paper, correct it, and let me know what you did on it.
What's the answer for?
I'm sorry, just wanna look at the thing.
Oh.
Okay, well, that's my problem.
How old?
Actually, turn that off. Hello? Thank you.
I got my. Can they see the answer? You're not done? Are you done with both of them? Okay, then I'm taking it. I'm taking care of it. Yeah.
That's all I know how to do it.
Yes.
Two variables.
Equal
That's
r
six.
squared. Divide that up.
No, we're not supposed to use it for.
Oh, okay, so you said, we're supposed to make that kind of thing. Just, if I could,
It's just M plus N plus.
put a number in here, and put a number in here, and that's when it's correct. And put the number in back. That's everything I can think